All right, good morning. This is Calculus 2, and you guys are going to do a whole bunch of calculus, and I'm going to teach you guys how to do stuff.
What if when they're watching it, it's not morning?
Huh?
What if when they're watching it, it's not morning?
I don't know. And, okay, what if they're, like, around the world? I'd say, hey, Dankeschön, or Guten Tag, or Ni Hao, or you know, Hola.
Cover your bases.
I know, right?
Good night.
You know what's funny? I actually had some people from Finland watch my videos, because you could actually bring up the all the stats on it and stuff like that.
Yeah.
So I actually had like a bunch of views from like this little area in Finland. I was like, all right, okay.
Some teacher that
I know, right?
Like,
They're like,
check this guy out.
yeah, that guy, donkey shake. All right, so.
Yo, shout out to all the Finnish viewers.
I know, yes, all you Finns, yes. Okay, just so you know, okay, yes, we like Leo, you know, the guy that does all this. Yeah, anyway, all right. Yeah, we're doing work. All right, so. Derivative of this is this. Now, okay, so I get a hint. Draw the circle. Okay, it's the circle of life here. So the circle of life, bam. So it starts off with positive sign here, then it goes cosine, then it goes negative sine, and then it goes to negative cosine. So if we're going this way, this is my dx. That is my derivative. So the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine, derivative of negative cosine is positive sine. Over and over and over again. Because we can do a whole bunch of those with a bunch of different, you know, like fourth, fifth, sixth derivatives. Yeah, so either way. All right, make sense?
Yes.
Good. All right, so find y prime. So y prime here is going to be 1 plus 4 cosine of x. Easy?
Yeah.
What rule is B?
Product.
Product. Okay, so product rule says I'm going to have, so it's going to be 2x sine x plus x squared cosine of x. Yep. And I could leave it like that, right?
Yeah.
Okay. I could factor, but you know, no point. Okay. If I was actually trying to get somewhere with this, I would probably factor it for some reason, or plugging stuff in, maybe. But as of right now, no. Okay, so anyway, all right, so, okay, so now, on this next one, C, what type of rule? Quotient. Let's do quotient rule on that. So derivative of sine is cosine x times x minus 1 times sine x over x squared. Okay, now, really don't need to do much with this. The only thing I would actually do is put the x in front of the cosine because it's times, and you know, negative 1 times sine is just negative sine, right? Okay. All right, do I need to do this one? D? No, it's a product rule again, isn't it?
Yeah.
Okay. All right, so same thing here. Bam. Okay, we just took care of it with the circle. All right, what rule do we have on this one? Say product. We got product again. Okay, product. So I'm going to have 2x cosine of x plus x squared times negative sine of x, right? So it'd be 2x times cosine of x minus x squared sine of x. Yes?
Yes.
Okay. All right. This next one might be a little bit more complicated, but you know what? It's still the same thing. So, oh wait, hold on. I have to make sure I label it f prime of x. All right. It's not lambda. Come on now. There we go. All right. So this next one. What rule do we have on B? Quotient. So quotient. So it's going to be. Let's see. That's going to be cosine. So negative sine of theta times 1 minus sine theta minus cosine of theta times derivative of this, so it's going to be, that goes away, the 1 goes away, and then negative sine is going to give me negative cosine of theta all over 1 minus sine theta square. Okay, so all right, so can we do some effing on this? Yeah, probably gonna need to, right?
Really?
Yeah. Okay, so watch. So I'm gonna distribute. So it's gonna be a negative sine theta
Plus sine squared there.
sine squared theta, and that's gonna be plus cosine squared theta all over 1 minus sine of theta squared. Now, is there one thing I could point out here? Yes, very good. Good job, you guys. All right, so we know this piece right here, from here to here, I could substitute that out. Sine squared plus cosine squared gives me 1. So I'm going to have 1. So now I'm going to rearrange this too as I do that. As I replace that, I'm going to change it to become 1 minus sine theta over 1 minus sine theta squared, right? Yes? And then I can factor out, right? So I can cancel out one of the 1 minus sine thetas. So it's going to be 1 over 1 minus sine of theta as the derivative of, what's this, g? Yeah, g prime of x.
I don't know. Maybe.
Yeah, I didn't feel like doing C anyway. Okay. Are we okay there? Yeah, here's another example of quotient. Okay. But, yeah. All right, we good? All right, so final points on the graph right here, there, where the tangent line is horizontal. Now, hey, you people, pay attention. Now, tangent line is horizontal means what? Slope is 0. So what do I actually write for that? I want to say what? F prime of x has to equal 0, right?
Yes.
That's what I need to get from there. Okay? That's what I need. So tangent line, so f prime of x is 0. So I need that. So now, first, okay, we have to find the derivative. Yeah?
Yes.
Okay, so, yes, so find the derivative. So for the derivative of this, so f prime of x is going to give me 1 plus cosine of x, right? So there's the derivative. Now, since we're going to set it equal to 0, I'm going to replace the f prime of x with 0 equals 1 plus cosine of x. Now, right here, so minus 1 equals cosine of x. And now, so from this point right here, we would do an arc, right? Arc tangent or inverse, arc cosine or inverse cosine. So either way, so it's going to be inverse cosine of -1 equals x. So what's that saying is, where on my unit circle is cosine equal to -1? Only pi, right? Okay. There usually is some type of like limits or bounds, especially on trig functions, because it is a wave, right? Since it is a wave, I want to make sure that I only get certain ones, because it can keep going the whole time, right? So yeah, so I'm going to limit to it right here. It's just going to be pi. So if it's at pi, and then when's the next one going to happen? At 3 pi, right? So at 3 pi. Okay, so it would be pi. So x equals pi. So that's what I'm going to get right here. So that's the point in which that my tangent line is horizontal. So that's going to be either a min or a max on here, right?
Yeah.
Okay, so we're not actually getting into the min or max yet, but you know, that's the point where it's actually going to start changing slopes. All right, make sense? Yes.
Yes.
Okay. All right. Derivative tangent is secant squared. So now at this point right now, I don't want to do the math on this, but I can. Do you want me to do the math?
Let's do it for the viewers.
Okay, yeah, for the viewers. Okay, donkey shake, you guys. Donkey shake. All right, so we know that we're finding the derivative of tangent, but what is tangent? Something over something.
Yes.
So we're finding the derivative. So if y is sine x over cosine of x, that's a quotient rule, right?
Yeah.
Okay, so now I'm going to do this as the derivative. So y prime should be, so it's going to be cosine, right? Cosine x times cosine x minus sine of x, right? Times derivative of cosine is negative sine, right? Of x. All that is going to be over. Wow, that's,
whoa.
Yeah, all right, okay. Over cosine x squared, right? Okay, so now let's clean up the top. I'm going to have cosine squared x plus sine squared x all over cosine squared x. And we already know that sine squared plus cosine squared is going to give me 1, right?
Yep.
So this is going to give me 1 over cosine squared x, where we know 1 over cosine is just secant, right?
Yeah.
There we go. So then it turns into my secant squared x. Bam. Educated. Alright, so yeah, tangent, cotangent, you know what, I can never remember cotangent for anything. I really can't. I don't know why. Okay, I do this every year and I still can't remember what it is. So every single time when I need it, quotient rule real quick, find the derivative of cotangent. Okay? Okay, and these other ones, what about secant or cosecant? Isn't that just 1 over sine or 1 over cosine? You could just do quotient rule on it to find it real quick, right?
Right.
Yeah, same thing applies. All right, here it is. Bam! All those right there. If you guys want to try and memorize that, you will actually have to memorize it here soon.
Are you gonna give us the flashcards again?
On this test?
Yeah.
Yeah, you will need it. But I am going to give you the flashcards.
Oh.
Okay? All right, so f double prime at pi over 4 if f is secant x. So let's see. F prime of x is, just flip the page. What's the derivative of secant? Huh? Secant tangent. Okay, so now what rule is that there? Product, right? Production.
Bless you.
Okay, so
Bless you.
either way. So now I could either do it like that, or I could say that tangent is sine over cosine, right? And secant is 1 over cosine, right? So couldn't that just be sine over cosine squared, right? So I could use product or quotient, either way. Either way, you could do both. Okay, if you know your trig identities, you could change them up to actually make it a little bit easier for you. Right?
Right.
Okay, so what do you want to do?
Let's do
Product.
Yeah.
Okay, so f double prime of x. So let's see. So derivative of secant is secant tangent, right?
Yo, it's like
Plus secant times derivative of tangent
Secant squared.
Secant squared.
All these
Okay, so what am I gonna have? So I could leave it as this, right?
Yeah.
Okay, it's gonna make it a little bit easier when I do this. So f double prime at pi over 4. Okay, so secant at pi over 4. So first, what is cosine at pi over 4? Rad 2 over 2, right?
Yes.
Rad 2 over 2, but flip that over and that's the secant. So it's going to be 2 over rad 2. So 2 over rad 2. Now, what is tangent at pi over 4? Think about pi over 4. Sine over cosine, right?
Yeah.
And they're both the same value, so it's going to give me 1, right? There we go. So I'm going to get 1 plus, again, secant at pi over 4 is going to be 2 over rad 2. And the next one's going to be 2 over rad 2 squared.
Then you forgot to multiply the tangent. The secant times tangent, that's the derivative of secant, but then you gotta don't you have to multiply it times tangent? The top one?
Oh yeah, the left side of the
Got
addition.
one tangent.
The left side of the addition, you just have f prime. You didn't multiply it by 2.
That's the
Oh,
it's
you're
basically
right. You're right.
tan-
I'm sorry.
yeah, it's
Okay, so
basically
secant
tan,
tangent times tangent, right?
Yeah.
Oh,
Yeah.
Okay, so this is also, I'm sorry, so put that in here, so times tangent of x, thank you. Man,
Finland people are just.
I know,
easy.
right?
They're probably screaming at their.
I know, you hear them clapping next door? Good job. They're. Okay, so now, when I multiply that in, what is it anyway? It's still 1.
Yeah.
I know, that's always great when you're like, you're wrong, but you still get the right answer. You're like, ha ha!
I'm gonna do it that way again.
I know, forget your math. I have
Wait,
tricked
why is
you.
it not working the second time?
I know, ha ha ha. Alright, anyway, alright, so going through, I'm gonna get, let me see, this is gonna be 2 over rad 2, and it's gonna become a plus, that's gonna be 4, that's gonna be 8, so 8 over 2 rad 2. Yes,
Yeah. Yep.
okay, so, let me see, multiply this by 2 over 2, right?
2 rad 2 over 2.
So it's gonna be 4 plus 8 is 12 over 2 rad 2, right? So, and then reduce and rationalize. So it's gonna give me 6 rad 2 over 2, which reduces again, 3 rad 2. Bam!
That's awesome.
Yes.
Incredible.
Okay, alright.
That's the fins.
Okay. So, right here. Now, this one right here, an object hangs on a spring, making the spring 2 meters long and in its equilibrium position. So if the object is pulled down 1 meter and released, it will oscillate up and down. The length of L of the spring after t seconds is modeled by the function L of t, 2 plus cosine t. Okay? So, it says, how does the length of the spring vary? It varies from what to what?
3 to 1. Yeah, 3 to 1.
3 to 1, right?
That's what I want to say, yes.
Yeah, right?
Yeah.
Okay, so it's going to 1 meter and release, and so it's going to go down to 3 and up to 1, right?
Yeah.
So it's going to oscillate in between there, right? Up and down. So it's going to release. So it's going to oscillate in between there. Find the velocity of the object. So we have an equation right here, right? So velocity is always the what? It's the what?
Change in position over
Yeah,
time.
there we go. Okay, so the length of the spring for this one is going to be the length, so it should be the derivative of that. So it's going to be L prime of t is equal to negative sine of t. So at what point is the speed of the object at its max? No, 2 is its equilibrium.
3.
If it's oscillating, think about it. If it's oscillating, does it, when you pull it down to 3, does it go all the way up to 1?
No,
It's oscillating because it's going up and down. Oscillating means it's getting slower and closer back down to the equilibrium. Right? It's going up and down, up to the equilibrium, and it's eventually going to get to the point where it stops again right there, right?
Mm-hmm. Yeah.
That's its equilibrium at 2. So where is its greatest length?
3.
When it's at 3.
When that t equals 0.
When t equals 0. Right? So when that t is equal to 0, let me see that right here, the velocity of the object, find the velocity. At what point is the speed of the object at its mass? Speed is the absolute value of velocity. So let me see.
Wouldn't it be at 2? Because that's when it's increasing until 2 and then it's decreasing until 1. Where
Yeah.
it's 0 and then it goes back.
You're right, sorry. So yes. Man, you got this, dang. All right, so if I were to, just to, dang. All right, so let's take a look right here. So to show this, so it's gonna be 2 plus cosine t, right? So 2 plus cosine of x here, enter. So right here, so at 0, we know that I'm starting there. So the graph of this, so let's go right here. So yes, you're right. So the first should be at 2. So it is right here. Pull this up. Analyze graph. Okay, so tab, escape first. So tab, so it is negative sine of x right there. So there we go. So it is, so absolute value, so it's actually going to be all the way at 2. Yeah, you're right. Yeah. So this one right here, it is going down, so it actually is, so this is negative, so it's actually should be at its max at 2 right here. So you're right. Dang, man. Someone on top of things, I'm not. All right, so let's see. So L prime of 2 is going to be equal to negative sine at 2, so that would be, I don't know, what's calculator say? So L prime of 2, menu, trace, graph, I want this one, and type in 2. So it is negative 0.909. So the speed, so speed is absolute value of that, so it is 0.909. And what are my units?
Didn't you say negative? Yeah, but it's absolute.
Speed. Speed's absolute value of velocity.
He's waiting for that.
And what's over time? Seconds, right? Yes, seconds. T is seconds. Find the acceleration of the object. Okay, acceleration is the derivative of the velocity. So take the derivative of negative sine t. So it would be, so L, I could at least keep the same L's. So L double prime of t is going to give me, so the negative sign is going to give me a negative cosine of t. And find the velocity. At what position is the velocity equal to 0? So let's take a look. So when is velocity, oh, I was saying velocity again, wasn't I? Acceleration of an object, and when is the acceleration equal to 0? So let's take a look for this one right here. Where is this going to be equal to 0? At pi halves? Okay, so at pi halves. So it should be pi halves, so that's going to give me about what? So it should be about what? Huh? It should be pi halves, but what's a decimal?
Oh, 1.57.
And that's going to be velocity. So 7. What was the next one?
1.
1. Okay.
Oh my.
I know, right? So anyway, so this is actually velocity, so it's going to be meters per second squared. Meters per second per second. Okay. All right. What position? Okay, there we go. All right. Hey, guess what? That's it. Yay! Now we're going to check the book to see how many of those mistakes I actually made. All right. Don't forget to like and subscribe.